Our next presenter is, the topic is oil spill scenarios, methodological approximations, sample results and potential application by Paula Pérez. Paula research interests have ranged from physical processes that occur at large ocean scales in the North Atlantic. One of her interests is also biophysical interactions relevant to the population dynamics of marine species in the region near the Pacific coast of Baja California. She's been coordinating one of the main research lines for CIGOM that she's going to be talking about today. Well, please, Paula.
Thank you. Thank you very much for the introduction, and thank you for the opportunity to show a bit of the work that was done in this project. And I'm honored to today. And you can see there's a large what we did to produce oil spill scenarios, methods briefly, also of how they were applied to the possible impacts on the ecosystem.
Paula, we can't hear you very well. Maybe you can get closer to the microphone.
Can you hear me? You can hear me? You can hear me now?
I hear it broken. Does everybody else?
Yes, it's definitely broken up.
It seems to be an internet issue, maybe closing her video.
Mm-hmm.
Yes, Paula, close your video if you can. Keep your screen shared open, just your video.
Let me stop sharing my screen.
Actually,
Can you hear me better now?
Yeah,
you have to do the operation then, because that was the sharing of my screen that was messing up. So you can hear me now?
Yes, better.
Okay, so then I need you to share my presentation.
Yep, I'm bringing it up now.
Okay.
You want? Yep, absolutely.
Well, anyway, I'll just continue saying that one of the main objectives that we have in the project is that we produce, well, we needed to say which regions might be affected by large oil spills in 6 different locations.
I think you're breaking up.
Yeah. Paula, maybe, are you using?
Yeah, I can't use anything but my headphones because my computer doesn't have a microphone, and this usually this application.
If I put a number in the chat box, I think it's a U.S. number. Not sure you'll be able to call it, but I can try that for you.
Okay. Mm-hmm.
no está disponible.
I don't know.
We can do it next time.
Maybe a local phone call, maybe Julio, and you can retransmit it.
But what do you mean? That I should make a phone call or what?
That you can phone call to Paula and put your phone call in the microphone so we can hear.
Yeah, that's a good idea. I have done that in the past, and sometimes it works.
Let me know if you want me to call Paula.
Yes. Why don't you try? Because
Yes, try, please.
She's almost there. Hang on a second, and I also have her on the phone.
And while we're waiting, if anyone has any questions pertaining to the other presentations, we're happy to take some questions.
May I ask a question to Jorge?
Go ahead, Juan Carlos.
Yeah. When you say that turbulent kinetic energy so stronger, I mean, in the Campeche Bay region, does it also imply stronger vertical mixing in that region? And if that is so, what do you think controls this mixing?
Well, this means that the current has a variability in that regions related to the mean current. That's exactly what it means, the turbulent kinetic energy. But of course, that means that there's more mixing horizontally and vertically. And that should be related to the variability of probably the circulation in that area, the Campeche gyre, and it can be related with its intensity and its displacement or its movement, or to both, I guess. And the figure I presented was not in the surface, was a subsurface, and the variability was very close to the slope or on the slope, over the slope. Yeah.
Okay, but is there physical control of it? I mean, is it modulated by some other force, but excluding the slope of that region?
Well, there are several studies that have been done in this project related with the Campeche gyre, and there's several contributions really for this variability.
Okay.
And yeah, I guess that's both the topography and the other forcings, which are the wind stress curl and loop current eddies indirectly that
Okay.
inputs that mass into and currents into that region, I guess.
Okay, and I had another question. When you showed the covariability of surface and deep layers, how deep is deep? I mean, how deep does this correlation go? Is the first 1,000 meters, or it's all the way to the bottom?
Well,
sorry to interrupt again.
Okay.
It seems like Paula is ready to present. But
perfect.
can you take note of the question, Jorge? Maybe we can address it by the end of the webinar. Very good. Paula, are you ready to go?
Seems like it. Can you hear me?
Yes, we can hear you.
Yes.
Okay.
Just speak slow.
Complicated. Anyway, let me start over then. So I'm presenting work that we've been doing as part of the GCOOS project. And, oh, sorry, let me just. Okay, can you hear me now?
We can hear you, yes.
Okay, so, okay, switch to making geez, here we go. Just tell me in the chat if you hear me, because I have to put everything off. Okay,
we can hear
I'll
you.
move on.
Mm-hmm.
So basically, we had to, can you get to that next slide, please? So we have to produce spill scenarios in 6 potential oil wells in the deep water of the western Gulf of Mexico, and the locations are shown in this image. And the idea was that we had to assess which regions might be affected by spill arriving from a large scale spill, and which ecosystems and species could be potentially affected by this. The next one, please. So this was really, as you can see, it's a very large, well, it's a very ambitious idea, and we had several groups working on this. We had, on the one hand, the group that was producing the model outputs for the circulation model outputs that Jorge talked about a little bit, that included both the atmosphere and the ocean. And then we had the group that was developing or using the oil spill modules to produce spills using the circulation models. And that information, once we have the scenarios that told us which regions might be affected, were used by the Ecological Vulnerability group that was trying to assess the impact on several different organizational levels, biological organizational levels, and they in turn used information from the environmental baseline that will be presented in another webinar. So as you can see, it was a very hard work in terms of joining a lot of different interdisciplinary groups and different institutions and try to speak the same language and produce things that could be useful for all. Next, please. And the thing is that, as you well know, that where the type of oil goes on a given oil spill depends largely on the environmental conditions at the time of the event. So in that sense, each oil spill is unique. And since we don't know when an oil spill might occur and which conditions would be available which would be present at the time of the spill, then we need to produce something that is more like a statistical product that allows to combine a large number of individual spills that were happening at different hydrodynamical conditions. And the idea of this statistical way of looking at it is to produce maps that would be useful for to plan ahead of an event, and in the sense that you can allocate resources and help prepare specific contingency plans, but they would not be useful for to act under a specific spill. So this is more like planning ahead. And the other thing is that you can use this information to evaluate ecological risk for certain species, families, and groups, which is what was done. And I illustrate this by these two images. The left is a spill that occurred in this X location under certain conditions that were found on the 1st of January of 2009. And on the right is the ensemble of spills with the same blowout conditions, but different environmental conditions that were set by the 1st of January of 20 years. There's 20 spills that were combined in an ensemble average, and it shows the cumulative map for that ensemble. And next, please. So the main idea of the scenario is that we have to produce something that shows the region that might be affected by oil, and also the times of arrival, the first time at which oil is expected to arrive. And this is an exercise that was done, I took this from Cosentino La Juara, but this is an example of how that would be produced. And this is it's a probabilistic approach of producing a scenario for the same location as the Deepwater Horizon spill. And the region that is painted with color is the region that might be affected by oil under any hydrodynamical condition. And the time of arrival is in days, is in color. And contours in black and in magenta show how the oil spread for the particular Macondo spill for day 9 and 27. And you can see that both the region where the oil was is contained within the region of the statistical scenario, and the times are more or less, fairly obtained of how long it takes for the oil to get there. Next one, please. So we did this both for the atmosphere. So that's also the pollutants that are released to the atmosphere when fires are done intentionally as part of the mitigation actions. But I will not present that now. But it's the same methodology was used to produce the regions possibly affected by pollutants in the atmosphere. And then we did it for the ocean using 3 different oil spill modules. Next one, please. And the 3 different modules were, the first one is a state-of-the-art spill model. It combines the plume model developed by Texas NAM, which is the near-field part of the simulation, with the open drift, that is the far-field simulation that has been developed by Norway. And this was combined into one single module that also had some improvements, like there were some changes in the evaporation scheme and some other changes, basically. But this introduces most of the effects that occur on the oil that is released in the ocean. Basically, all the processes possible are parameterized by this 3-dimensional model. But we also use 2 other models that are simpler and are 2-dimensional in the sense that they can only assess how oil spreads. They're far field and they represent how oil spreads in one single vertical layer. And these are produced by plastic particles, including windage, and the decay is only by evaporation, which is the largest process involved in removing oil from the ocean. And the oil spill one is basically produces individual spills at each location, and this other spectrotrans is based on Markov chains. So in that sense, it produces a transition matrix that tells you statistically or probabilistically what the likelihood of oil in a given bin, a geographical bin, is, what the probability is that oil will spread bins over time, how it will spread on the other bins surrounding them. So in that sense, and this includes all the hydrodynamical possibilities for O2 spread. It's also based on passive particles with windage and decay by evaporation. But the difference is that once you have the transition matrix, you can very easily produce scenarios for any point, while the other two, you need to produce a lot of individual spills for each location. So they are more computationally demanding, particularly the 3D model. Next, please. So, and this was just to show that there's a lot more work that went on to be able to assess what the possible impact on the ecosystem would be. I will not be able to talk about that, but since I'm going to show you some results on how those were applied, I'll just say that ecological vulnerability was assessed both at the levels of species, families, and order of some selected organisms, but also at the ecosystem level, or at least an attempt of doing it at the ecosystem level. And there were also experiments where the effect on plankton and bacteria were studied under different concentrations of exposure of oil of different concentrations with mesocosms and also with bioassays for fish. And lastly, even though this is not a vulnerability assessment, there was biological connectivity was also brought into place to assess in some way the resilience of certain populations to recover after a spill. Next, please. So, I won't have much time, and especially after my hiccups. But the point is that I just want to say briefly how we produce these scenarios. And I guess there's a plume here. I don't know if you can make the video work. It doesn't matter. And the right is simulating the plume that we use for the SAMOC model. And what we did was produce individual spills that start on the first day of each month of the 20 years that we have simulated with the circulation model. The spill lasts 15 days with a constant mass flux, but that was selected between the Macondo and the Ixtoc spills in the Gulf of Mexico. And well, the spill lasts only 15 days, but I can just say that the results saying which regions will be most likely affected do not change if you change the time the spill lasts. But obviously the amount of oil that reaches those regions is going to be larger the larger the spill lasts. And the oil was tracked for 2 months after the spill started. We used 3 different kinds of oils, generic oils, because we didn't know exactly what oils are expected to be found on the wells that were given us by Pemex. And the analysis was done over a quarter grid for the top 20 meters, because the conditions we used, the blowout conditions, which were we just only used one single blowout condition, and that one resulted in most of the oil getting into the surface. So we analyzed up 20 meters, and we did ensembles of all of these oil spills for the 3 seasons that we divided, which are lluvias, nortes, and drought or seca. And we also did it for the global using all the spills. Next, please. And the thing is, we have 3 modules. We have also circulation models that are 3 circulation models. So we had a bunch of combinations how this was done. And particularly for the third one, which is easier to run, the Petrotrans, we did it for the 3 circulation model just to assess the sensibility to use different circulation models for producing the scenarios. Next one, please. So just an idea of how this is done, like the metrics that we use is that we use all the oil spills for any given season that we want to produce the ensemble. We calculate the mean mass fraction over all individual spills, and then we look at the maximum fraction achieved over the 60 days that we follow the spill. And that's what this map is representing in red on the left. And the region where we decided would be the region which is most likely to contain oil from any given spill, is this region that is this contour that shows that 0.1% of the total mass released during the spill. And by the way, if you do it probabilistically, that accounts for, you have a 70% probability of finding oil from any spill, or finding more than 0.1% of the mass of oil for any spill using this contour. Next one, please. And then the hit time would be how long does it take for the first time to achieve that 0.1% mass, that amount. So next one, please. So I'll just briefly, I'll say that there were no significant differences between the circulation models. If you use any of the models, you don't really get very different regions affected by when producing the scenarios. Next. And we don't, there are differences in seasons for sure, and some of the locations show larger differences in seasons, but really the most difference, next one, is found when using the different modules, and particularly one before, please. Particularly if you use, no, before. The big difference is by using the 3D state-of-the-art model and the two-dimensional models that are simpler. Well, you can stay there if you want, but basically, what I'm showing on the left is the one, the titles are mismatched. The left one is the state-of-the-art three-dimensional module. I'm sorry about that, which is a TAMO plus open drift. And on the right, you have the simple 2D model. And you can see that the area, well, the contour, the black contour represents the 0.1% mass fraction, and obviously they are very different. In the sense, not in the sense of what is the coastal area that might be affected, but certainly the extent at which it extends to the open ocean. And we think, although we haven't analyzed this clearly, but this is true for both of the two-dimensional modules that produce similar results, that the reason why this is happening is that the entrainment process, which is by which oil from the surface is moved vertically down by waves and the turbulence that happens on the top layer. So you're removing oil that was at the surface and pushed directly by the wind, and that allows it to not be pushed by the wind towards the western coast, which is the reason why most of the oil reaches the western coast in the 2D modules. And we know that because if you remove the windage, you get something similar to the 3D module. So in that sense, the area will be different, and not so much the coastal regions, although most of the coastal regions are also shown to be affected, but the deep ocean is the one that is really different. So reality, and the thing is that we think that which one do you believe more? It's hard to say. You know, the entrainment process is something that is yet poorly understood. It's parameterized, and it's not easy to test in real conditions. So we don't know if the 3D module is, overly making oil removed from the surface and be less exposed to the wind. And on the other hand, the 2D modules are definitely overrepresenting the windage effect. So reality lies somewhere in between, and we would need to do more research to really get to answer this better. But the idea is that the difference between the two, tells us the uncertainty of producing these kinds of scenarios. And what we said to the ecologist friends that were going to do their vulnerability assessment is to use the precautionary principle and basically use the worst case scenario for the particular assessment in question, meaning that if you're going to be concerned about coastal populations that are mostly on the coast, you would use the one with the 2D module, and if you're more concerned about what happens in deep water, you would use the 3D module. Next, please. So just briefly, this is an example of how this was applied for some of the pelagic fish, in this case, Yellowfin Tuna. What they did was overlap the habitats with suitability for yellowfin tuna, which is shown in color, with the scenarios of the oil spills and the regions that might be affected by oil, and make some assessments. For example, for the wells in the north, most of the billfish like tuna could be affected, since that covers most of the area where they tend to be. While for the southern ones, it's mostly sharks and rays that might be affected. Next, please. And this is just to show other products that were developed from these ideas and the vulnerability studies. This is a geoportal for habitats and vulnerability of marine turtles. I'm showing here the cumulative vulnerability of turtles to several different stressors in color, and then the contours in color show the scenario of an oil spill scenario for a particular well, and they do make some assessments of which turtles, which species might be mostly affected, which habitat, and so on. And they actually joined with a very large response and response teams and the officials that need to respond to such an event, and created a response plan specifically for marine turtles based on this information. And you can find that on that website. Next one, and that's the last one. And then all of the information that I just briefly summarized here is in a literary collection in Spanish. You can find in this link, and we have three volumes. The first one talks about everything from the methodology and the results of the scenarios for both for the atmosphere and the ocean. The second one has all the ecological vulnerability assessments. And the third one is the one related to biological connectivity and the possible effects of spills. And all of that is summarized in the top, which is an executive summary that is basically showing most of the most important results, and it's written mainly for decision makers in the hope that they could use this for both policy and for planning purposes. And next. So thank you, and I'm sorry about the problems, and now I'm going to see how I do to listen to you.
Thank you, Paula. Well, we have still a large group connected, listening to all this great research that you have presented. And I guess that there might be some questions that will be asked to Paula and to Julio, who presented before, or Jorge. We wanted to have this last chance for asking questions at the very end of the meeting. So if you have any question, just raise your hand or just formulate it directly on the text box, and we'll be happy to share it with the presenters. So, well, we wait for anyone to formulate a question. If there's any question, I have a question for you, Paula. How does your simulations compare to others? You show a comparative analysis between two different methodologies. Are these the only two existing methodologies available to simulate oil spills?
Well, no, the methodology, sample methodology, many ways of doing so. We learned that later by talking to some of the Pemex people, but the idea is the same. Maybe the metrics are different, but the idea is the same. You produce a lot of individual spills, and then you produce a statistical map that shows the regions that might be mostly affected. And we had very similar results just by looking at what they had produced for one of the wells that we also did. But we haven't been able to do that in a more, quantitative way. Now, in terms of like how many oil modules are out there, there's like how many oil spill models exist. Yeah, there's that would be a different undertaking. Like we do use 3 different ways of doing it. One of the state-of-the-art there might be more. There's some commercial ones that we didn't use, for example, because we don't have any control over them. But we know that both the plume model and the far field models have been tested in many ways, and they're actually very, the community that does this considers them as appropriate. But it's they have done their own tests, although that's really difficult to test in water, except for testing how they do spills that have occurred in the past and the open roots, and some of were shown to produce more or less what occurred in the deepwater horizon. But there's many things that are parameterized, so then you can play with those things, and that gets complicated. But in terms of we didn't do though the scenarios except for the deepwater horizon, we didn't do one for stock to see how well we reproduce this by the 3 different oil spill modules. So that would be something to be checked with. But in the end, you summarize, you see the variability of just using a 2D versus a 3D model, and you can see how different the outcomes can be.
Thank you, Paula. There is a question by Gerardo Gold, raised his hand. Gerardo, would you like to formulate your question?
Yes, thank you. And thank you for the presenters for their excellent presentations. It's just a small request to Julio. Could you please send me the references you cite in your presentation? I mean, you don't need to send me the file, just the citations, please.
Yeah, actually the links and the links to the papers are in the summary of the seminar. If you go there, you will find the links there too. But I will send them to you anyway.
Okay, thanks a lot.
There is also, I don't know, a question by Nuno. Nuno, do you have a question you would like to formulate? We cannot hear you, Nuno. There is also, I guess, a question by Yun Liu. Yun, would you like to formulate your question? Okay. Well, we didn't get a question. There is also a question marked by Alejandro Dominguez. Alejandro, do you have a question you would like to formulate to the speakers? Okay. Paula is sharing with in the chat box, and Sharon as well, the links to the publications that summarize the work that Jorge, Julio, and Paula share with us today. By the number of attendees still connected, this just shows the great interest that there is in the Gulf of Mexico community to learn about what CIGOM has been doing in the past few years. Any question, last comment that anybody would like to make? Any comment that the presenters would like to make before we adjourn the webinar?
I'm trying to share the links, but can somebody that is a panelist please share them to everybody, because it doesn't allow me to do that. There's 2 links, one to the publication, the recent publications of CIGOM, which is also in our CIGOM website, and also the link to the books that Paula mentioned. But I need somebody.
I also included the geoportal for turtles.
Can you add that, Paula? I don't have that link. Okay.
You couldn't see it? Okay, no, they can.
Yes, that one can be, yeah, they can see them. Thank you.
There's one more.
The geoportal, MDA. And then before that in the chat, you can see the one for the Atlas, which is public as well.
Very good. Any final comment or sharing that you would like to make?
Hello, can you hear me?
Yes, who is this?
Hello. Yeah, this is Byung-Jin Kim from the Texas A&M University. I am working with Dr. Sokolovsky, which is dealing with TAMOC simulation. And I have a question for Paula.
Yeah.
And like you mentioned about the 2D modeling, right? And I wonder like how it really works. Like it's a 2D modeling, right?
Yeah, what we did is that, you know, the fluke model gives you the information for the far field model.
Uh-huh.
So what we did was to, let me just, hold on, is to, those results, which is how the oil spread and the vertical, particularly in the top 20 meters, yeah, the flux that was reaching that layer was put into the two-dimensional model particles that then were affected just by the currents and by the wind.
Yes.
And then you put some decay. So it's the simpler way.
Okay.
That's how they work. The probabilistic one is a little bit more complicated, but it's based on the same type of simulation of how the oil particles move.
Okay.
And you know, like the first example I showed you from the scenario in the Deepwater Horizon still was produced with those. So it's not too bad, you know, but it doesn't have all the nice things that the three-dimensional model would have in the far field, which is open drift.
Very good.
Oh, yeah, thank you.
Very good. Well, we went way beyond the original schedule we have for the webinar, but again, I think we don't get to see Jorge, Julio, and Paula together that often. So thank you very much for the time and for the sharing of your work in this webinar. And again, if there are any questions, I guess all the links have been shared to GCOOS, and I guess GCOOS can forward these questions to the presenters today. Well, thank you very much, Jorge. I don't know, I guess you want to have a final word here.
Just to thank you, Zenon, for the moderation of this session. Thank you, and the rest of the team and presenters, of course, Julio, Paula, and Jorge. Thank you so much for staying with us. This was really informative and exciting for us to hear from here in the northern part of the Gulf of Mexico.
And to Jennifer, who helped us with the hosting and management of the system. So thank you, Jen.
Absolutely. It was such a great presentation. You guys did a wonderful job.